guys, right? Because I think Fatiha, yes, Fatiha, you asked last time whether you can access the resources or not. Like, I mean, not resource, I mean the notes, right? And the recording and all that, even after the classes. The answer is yes. The answer is yes, okay, because the IT person we clarified with me already. So they will be putting on all the notes, like, okay, all the annotated notes on this. So I'm sure all of you, I think this is your dashboard, right? All of you, right, would have seen this. This is how it looks from your side, from your point of view. So for me, over the weekend, I'll be collecting all my notes, make sure everything is complete, and then I will send it to the IT guy lah. So hopefully by next week, you guys just go until under this tab, resources, okay, resources, and then under reading materials and recorded lectures. So I snapshot this morning. So looks like they haven't started uploading it except for the science classes lah. So for maths, yeah, for maths, I will be collecting up all the annotated notes and all that. I will send them over to the IT team, okay, for them to upload. Hopefully they'll upload it by next week lah. Okay, so that being said, let's start our last lesson lah. Okay, let's start our last lesson. Statistics. Okay, so statistic, you have two main component, I would say. Actually, let me just write here, okay? Yeah, I just realized, yeah, I just wanna put a quote here because this one I always share with my students lah. Whatever you guys are doing, right? For your academics, okay, whatever you guys are doing for academics is all about winning, right? It's all about like competition, must get a lot of A's and all that, right? And then you work, the harder you work, the more A's you'll get and all that. But I always, since this is the last class, okay, so allow me just to share. I always tell my student, in real life, is not like that. It's not like you put 100% effort, then you for sure will get 100% return in real life. It is not, because the return that you get, right, sometimes it depends on your surrounding, your environment, the people you work with, the situation that you are in. For example, is it like COVID and all that, like, right? So but then how do we determine whether we do well in life or not? So that's why I always share this with my students. It's never the one that keep working. Like you want to go very fast. It's never those people who win one, right? It's always the people who never give up. Okay. So one of the things that you guys, okay, you persevere all the way until the end of lesson. The attitude is the one that counts. Right? The attitude is the one that counts. So I wish you guys first lah, for sure, best of luck for your SPM. But one thing I want to say is, if lah, touch wood lah, your SPM result eventually didn't come out as what you expected, okay, please don't beat yourself down. This is the worst thing you can do to yourself. Please don't self-blame, blame yourself. Why I like that? I should have done better. Stop doing that. Okay, don't do that. Don't do that. You can work as much as possible before the test, but after the test, you have to let yourself go already. Okay, this one I always tell the students. Okay, so let's just leave it there. Okay, so let me give you guys an overview. Okay, so for stats, today we're gonna cover stats, right? There are two types of questions. One is what we call ungrouped data. Don't worry about these terminologies lah. Basically, I give you an example of ungrouped data means something like this lah. This is not ungrouped data. It's the data is individual lah. It's individual data, concrete, discrete data. Okay. Another type is this one. Let me go all the way. This one. This one, you see? The data is within the range one. It's like there are 4 people that's from 55 marks to like 59 marks. 6 people from 60 to 64 marks. Like got range one. This one we call it group data. The data is grouped up. Like that. Okay. So today we're gonna cover both. Okay, group data. Okay, so both of these, what is the same for both of these is the calculation. Okay, so what is the same for both of these is the calculations. Okay, so what calculations are you required to do? Okay, so for calculations, there are two types of calculations you are asked to do. One is calculate the averages. Now, there are three types of averages. This one you would have learned in your lower secondary. Mean, mode, median. Okay, this one you have already learned in lower secondary. Okay, so these three, depending on what the question asks you to find lah. Okay, but either one, any okay, wait, let me pull this down. Let me put it here. Okay, so but either one of them is going to tell you the average lah, the average. So let's just say if I compare two groups, one group has a higher average. Let's just say one group has a higher mean, one group has a higher mode. The one with the higher mean, mode, and median, we say that group has a higher average. Okay, score better lah, in other words. Okay, so later we'll go through for each of these how to do how to find. Now, when you go to upper secondary, you learn this consistency. Measurements for consistency or measurement for dispersion, they basically mean the same thing, okay? So disperse means spread out. So if the data is very consistent, means the dispersion is very small, means most of the data is very concentrated. Concentrated means very consistent, okay? So in order to measure consistency, okay, we do four. Got four. Okay, got four. The first one is range. The second one is I write the full name first, but moving forward, I'm gonna write the shortcut for this, the short form for this. The full name is interquartile range, but I always call it IQR. Interquartile range, like that. Okay. So okay, very quickly. Actually, I did have a slide at the bottom. Okay, don't worry. So later we'll go through the formula for each of them, okay? The next one is variance. Okay, and of course, never forget standard deviation. Okay, standard deviation. So you see, guys, whenever you study a topic, you learn something, right? It's always good to have a mind map. That's why you see, I share this with you, right? I share this with you. This is like a mind map. So you always start from a bigger picture, and then you dive deep. This one, why is this good? I share with you. When you go to college, of course, after you SPM, you go to college. And then after that, you go to university. When you go to college and university, if you go to, depends on which college you go to, okay? Some lecturer, they might still teach you step by step and all that. But I would say maybe 50%. Because they treat you as an adult already. And you should. And you should, because when you go to college, that means you're 18 years old already. Technically, you're an adult. So this mind map, you should come up for yourself. If the teacher never give it to you, you can't blame them. Because as an adult, you should know how to do this already. Okay, so I show you this is how you study. When you go to uni, even more. You have to do this even more. University, the lecturer just basically just deliver what they want to deliver. You understand or not understand, that depends entirely on you. So this, having a mind map. Okay? So this one, both calculations we'll go through later, all right? For both ungrouped data and group data. Okay? Now, additional learning for group data after this is, of course, drawing lah. Okay, the histogram and then the orgif, I don't know. Okay, this one, right, drawings lah. This one you guys need to know how to draw. Okay, for ungrouped data also got drawing. This one we can draw box plot. Okay, box plot, later we will draw. Okay, I think so. Oh, stem and leaf, there's another one. Stem and leaf also can draw. Stem and leaf, that's it. Okay, so this is the big picture of the entire everything you need to know for statistics. Okay, okay, so with that being said, let's get started. Okay, so for mean, mode, and median, okay lah, just very quickly lah, mean, mode, median. I hope you guys remember averages. First one is mean. Mean means you sum all the data, okay, add all the data divided by the number of data. Okay, this one is mean. Mode, how you can remember this one, mode easily, is that mode, MO, sounds like most. Mode sounds like most, right? So this is how you remember that. Okay, so mode means which data appear the most time. So this is how I remember. So data that appears the most. Appears the most time. So this is mode and most. Okay, and then of course the last one, median. How I remember, median sounds like middle. Median, middle sounds similar, right? So which means it's the middle data lah. The middle data. Done. Okay, this one is from lower sec. Okay, but in upper sec, this four is the one that you measure of dispersion. So normally, right, if the question asks, okay, which one should you measure to what to learn what is the term they use to measure the consistency, they love to use the word consistency. So out of these four, which one is used to measure consistency? Normally the answer that they accept is this one, standard deviation. Okay, so you just answer standard deviation. Okay, but actually you want to use range, you want to use interval range to get a gauge of the consistency, also can one. That's why it's all under here. Okay, but the SPM answer for that is standard deviation. Okay, so for range and interquartile range, right, these two is, I don't think it's given. I don't think it's given in the formula sheet. Okay, so this one you have to remember lah. Range just means take the largest data lah. The largest data minus off the lowest the data with the low data with the largest value minus the data with the lowest value. Okay, this one can lah. So that's basically you find out what is your maximum lah. Find the maximum minus the minimum. That's the range. Interquartile range, you use the third quartile. The symbol is this, Q3 minus Q1. Don't worry, later we will do a question on that. Okay, so I will demonstrate how to find both of these. Variance also, do I have a space? Yeah, okay. So we'll demonstrate how to find variance and standard deviation. Luckily to you, variance and standard deviation, these two formula are given. Okay, so under variance, if you look at your formula sheet, there are three formulas they gave it to you. Now I don't like to use the first one. I feel like the first one is very troublesome. Okay, I don't like to use the first one. So you guys just see, I highlight some more for you. If it's ungrouped data, okay, ungrouped data, okay, then you use this formula, the second formula, to find variance. Don't use the third one. Okay, ungrouped. Okay, you know what? Let me just color code this lah. This one. Okay, nah. Yellow color means for ungrouped data lah. If they ever ask you to find the variance for ungrouped data, you use this formula. Find the mean for ungrouped data, you use this formula. Both formula of mean are also given in the formula sheet. Okay, so you just need to know when to use which. The other one is for group data. So this one green color. Because why? For group data, right, you will have frequency. This F stands for frequency. So if there's ungrouped data, then you use the third formula with the frequency here, group data. So same thing for mean. If they ask for mean for group data, you use the one with the F, frequency F here. I wrote here, F means the frequency for each data. Okay, so don't worry, we will go through each of them, how to solve. Last one, standard deviation, very easy. All you need to do is just find the variance and then square root the variance, you will get standard deviation. Okay, so I purposely wrote here, you guys, you see, for each of these, if you find the range, you go and find the interquartile range, you go and find the variance, you go and find the standard deviation. If all of this value is small, the smaller this value goes, that means it's more consistent. In other words, smaller dispersion slash better consistency. So actually, If you want the data to be very consistent, actually you want these values to be as small as possible. Okay? So smaller value, better consistency. Okay, done. Okay, so that's it. Okay, this one, let's do this for ungrouped data first. You see? This one ungrouped data means all the data is individual. Okay, so let's do it. This one is from Terengganu. Okay, so I hope your pen, paper, pencil, everything is out. Calculator, everything is out. Okay. Okay, come, read the question together. Okay, so table 2. Okay, this is the table 2. Show a set of data. Sure. So this is a set of data. So what do they want you to do? Based on the there you go. Construct box plot. Okay, construct a box plot in the answer space given and hence find the interquartile range of the set. Okay, so I purposely chose this question because I want to demonstrate box plot. Okay, if you know how to draw box plot, please go ahead. Don't wait for me. Okay, don't have to wait for me. All right, let's go. So for box plot, right, how does the box plot look like? It looks like this. 1, 2, 3, 4, 5 lines. 1, 2, 3, 4, 5. The gap doesn't have to be consistent. The gap doesn't, as long as there's 5 lines. And then what you do is you make a box with the middle 3 lines like that. Okay. And then the other 2 is like a whisker, like a yeah, like whisker lah. Okay, cat whisker. Okay, like that. So always, whenever you draw a box plot, you always start from these five lines. 1, 2, 3, 4, 5. After you mark these 5 lines already, then you connect the middle 3, and then the other 2 just draw like that. This is a box plot. Okay, now what does these 5 values mean? What does these 5 values mean? So easy. This value means the minimum value. So out of all of the data, what is the minimum value? You find. And then that will be where the minimum value is. Of course, all the way to the other side, this must be the maximum value. Okay? And then, of course, in the middle, I told you already, middle sounds like median. So median, you should put in the middle. This median. So that means later on when we look at this data, right, you have to find out what is the minimum, what is the median of the data, what is the maximum of the data. Okay, and then the other two here, this one we call it the first quartile, Q1. This one here is the value of third quartile. Okay, this is how you should do it. Okay, so now let's see. In order to find mean, Q1, median, all that, right? This data, first step, you must arrange it first. You don't tell me, oh, teacher, count how many data, 1, 2, 3, and then straight away find, oh, the middle is here. No, must arrange first. If it's ungrouped data, please make sure it's arranged. If not, very hard for you to do anything. Okay, unless they ask for mean, mean don't have to arrange lah. But this one obviously needs to arrange, right? Okay, so let's arrange this. Okay, looks like the smallest one is okay, so 20 something, right? So for me, okay, this is another quicker way. This is another quicker way to arrange. You know 20 something is the smallest, so you highlight all the 20 something first. Okay, so done. That's all the 20 something. So out of this 20 something, which one is smallest? Looks like it's 21. Okay, so let's rearrange that. 21. So 21, 2, 1, 2, 5, 6, 7, 8. 2, 5, 6, 7, 8. This is how you can arrange very quickly. Okay, then the next one, of course, is all about the 30. So 30, 38, 39, 32, 34, 36. That's it, right? Yep. Okay, now you arrange the 30s. So 30, 2, 4, 6, 8, 9. 2, 4, 6, 8, 9. See, very fast. Okay, and then lastly, is the fours. So 0, 2, 4, 6 lah. 40, 2, 4, 6, done. Okay, I always do this. For me, I always double check and count how many data are here. 2, 4, 6, 8, 10. 2, 4, 6, 16 data. So check, do I have 16 data over here? 2, 4, 6, 8, 10, 2, 4, 6. Good. That's how I know I got it. Okay? Okay. So once you reach, okay, first thing first, minimum and maximum is very, very clear already, lor. Correct? This must be the minimum, smallest value. So 21 has to be here. Here, this is the maximum value. So 46 has to be here. So that means you see there's a grid for you. There's a grid for you. So you just label nah. So, okay, let's zoom in. Let's zoom in, because we want to find 21, minimum is 21. So I think there are 10 boxes here, right? 21, 2, 3, 4, 5. Yeah. So 21 is right here. So you just draw like this. As long as possible. Actually, it doesn't have to be as long as possible. Just a straight line here. Okay, done. Here. That's 21. Okay. Then maximum 46. So fine. Okay, 46 is here. So approximately 46 is here. Okay. Straight line lah. So this one here, 46. Done. Okay, this is my min and max. All right, median, easy. Median, remember just now we counted 16 data, right? 16 data. So the middle one should be between the 8 and the 9 data. So 1, 2, 3, 4, 5, 6, 7, 8. So should be here, right? 8 here, 8 here. So the middle should be here. This is where the median is. Here, very ugly. I cannot tahan. Okay, like that. This is where the median is. Okay, so you guys need to find out what is the middle between 32 and 34. Now, if you guys don't know what is the median, let's just say this one I think is easy, it's just 33, right? But if you want to do actual calculation, what you can do is just find the average between these two numbers. Average between these two numbers is only the same as the middle number, right? So how do you find the average? You just take 32 plus 34 divided by 2. Press in calculator, you will get 33. Okay, so our median here is going to be 33. So fine, where's 33? 31, 32, 33. So here. Okay, here. Okay, done. Okay, so I don't know you guys realize or not. You see, I always start from min max. And then after min max, I go to the middle. Then only I will go to Q1 and Q3. Why? Because Q1 is just in between the minimum and the median. Is in between. So you should think of it like this. The whole data, right? You chop in the middle is median. Okay. And then for the first half, if you chop again in half, that is your Q1. And then your Q3 is basically the second half, you chop half. That's Q3. Okay. So if you look at the first portion here, you have 1, 2, 3, 4, 5, 6, 7, 8 data, right? So you chop half again, means here lah. This is going to be your Q1 already. Q1 is half of the first half portion. So your Q3, 1, 2, 3, 4, just here, Q3. This is how you do. So actually, you don't have to confuse between your Q1, Q3, the median, all that one. Very easy only. You find the middle and then you chop again. Then it's like Q1 and Q3 already. Okay. Okay. So again, looks like Q1 is in between 26 and 27. So if you guys want to, of course, you can do the average again. These two values add and divide by 2, you will get 26.5. That's your Q1, 26.5. Okay. Q3, same. 39 plus 40 over 2, that is going to give you 39.5. Okay. Done. So now with this, okay, we can plot nicely already, your box plot. Okay. So this is 26.5. Guys, be very careful here. 26 is right here. This is 26. 27 is right here. So 26.5 is right in between this one here, 26.5. So must be very accurate, guys. Okay, good enough. Okay, 26.5. Same thing to do with the 39.5. Okay, so 39 is here. 39.5 is right in the middle. Right, this one here. Okay, like that. Okay, done. Then you see 1, 2, 3, 4, 5. I got 5 lines already. Now I can connect it nicely. Ta-dang! Okay, so the middle 3 just connect. Oh my god. You use ruler lah. And then this one, right in the middle like that. Okay, done. This is my box plot. Okay. Oops. Done. Okay, so actually, if you know what to do, actually, this is also a 3-mark question, right? Quite easy, right? Just find out these 5 values, then can ready. Let me highlight. This is the most important one, the 5 values for box plot. Okay, all right. So the question is asking you to find the interquartile range. So if you you know what? Let's just find all. Let's just find all. The range can find what? The range can find. Range, if you remember, is the maximum value minus the minimum value. So that means for this case, it's going to be 46 minus 21. If they ever ask for range, that's the answer, which is what? 25. Done. Okay. Interquartile range, I'm going to write IQR, short form, IQR, interquartile range. Okay. This one, very similar to range, except instead of using the max and the min, you use Q3 minus Q1. It's just like smaller. Okay, it's like we take a closer values here, Q3 and Q1. So Q3 minus Q1. Done. So our Q3 is 39.5 minus Q1 is 26.5, which is 13. Okay, done. See, 4 marks already. Okay. So I know the question never asked for it, but I wanted to demonstrate using the same data, the ungrouped data, we can also draw out a stem and leaf. Okay, we can also draw a stem and leaf diagram. So very quickly, how to draw a stem and leaf diagram? Okay, of course you must have the stem first. Okay, and then so how to do the stem? So just now, you see, luckily I arranged my data nicely here. I already arranged my data nicely here. So looks like my stem, the first stem is 2 lah, 20 something. All the 20 something, I can group it under stem 2. So I got 21, 22, 25, 26, and 27, and 28. So 1, 2, 5, 1, 2, 5, 6, 7, 8. So I just write here in the leaf. 1, 2, 5, 6, 7, 8. This is how you do stem and leaf. That means, right, whenever if you read, if they give you a stem and leaf, they ask you to read this value, and you don't tell them, you don't tell them the data is 5, you know. What this means is this data means 25. You must read the stem and the leaf together. Okay, this means 25, not 5. Okay, so that's how you do stem and leaf. Okay, very quickly, let me just fill it up. For 30 something, I got 0, 2, 4, 6, 8, 9. 0, 2, 4, 6, 8, 9. Okay, done. For the 40 somethings, I have 0, 2, 4, 6. One more thing also, when you guys do the stem and leaf, please make sure it's in order. Please make sure it's in order, from small to big, from small to big, from small to big, like that. So just by looking at the stem and leaf, right, actually you can also find the min and max very easily, because you know the first number must be the minimum. This 21. Hey, please don't read this as 1. It's 21. And then the largest number here, the 6 here, which means 46. Like that. Normally, they will give you something like this also lah. They give you like key. It's like they give you this key. So 2, 1 like that means 21. They will give you this key also underneath the stem and leaf diagram. Okay? Done. Okay, so that's it. Okay, here also I add on lah. Okay, just to demonstrate to you lah. With the same data, we can let's find out. Let's find. Okay, what is the value of mean? What's the value of variance? And what's the value of standard deviation for this set of data? Okay, so just like I told you already, you ask yourself, what is this data here? Ungrouped, right? Here is an ungrouped data, right? So if it's ungrouped data, then I told you, ungrouped data, you use this formula without the F. This one got F, don't want. Use this one. Ungrouped data doesn't have frequency, so use this one. Mean, also use this one. This one got F, don't want. Okay, ungrouped data doesn't have frequency, so use this one. So let's copy down the formula for mean. Okay. So the formula says this. The symbol for mean is like this. Okay, X bar. Sum of X over N. This one from the formula. See? Okay, so all you guys, don't get confused with all these symbols. Don't worry, right? So what does this symbol mean? What does this E mean? The E just means sum lah. Sum means add everything together. Okay, add everything up. Okay, did I have a... Oh no, yeah, I didn't have a... Okay, so I just make sure the symbol is clear. This symbol here, this means sum. Okay, sum of what? Sum of what? Sum of this X means the data lah. X means the data. So that means you are supposed to add up all the data lah. That's what it means. Okay, so all this data, okay, actually I wrote it here already. So all this lah, 21, 22, 25, 26, all the way you add all the way until 46. Everything, all the data you add up. That's what it means. Sum of the X. X means the data. Okay, add everything up and then divided by, okay, you must know what the value of n means. No? So I did write it here also. Value of n means the total number of data. Just count lah. How many data are there? We counted just now, 16. There are 16. If you count one by one, there are 16 of them. Okay, done. So all you need to do now is just take out your calculator. I think this chapter, nothing much. And because most of the calculation, you can do it with the calculator. All you need to, and then the formula also mostly also given to you already. So you just need to know how to use the formula and when to use which formula only. Okay, nothing much. So this one you calculate yourself lah. Do I have an answer here? Let's see. Yeah, I do. Okay, so this one if you calculated everything, then the answer should be 33.125 lah. Okay, done. Okay, next, variant. Same thing, variant, formula also given to you, okay? So the symbol for variant is like this. This symbol is actually for standard deviation. But we know that variant is standard deviation square. That's why when you found the answer for variant, for standard deviation, all you need to do is just square root the variant only. Okay, so that's why standard deviation, the symbol is like this. It's like this. Okay, so variant is the standard deviation square. Okay, so again, the formula you use is this one for ungrouped. So let's copy that down. Sum of x square over n minus x bar square. Okay, that's the formula. So you see, you just need to know how to read this formula only, then you know what to do already. Okay, what does this mean? Sum of x square, well, x, remember, it was the data. So that means, right, they want you to sum up, they want you to add up the data squared. The data squared, that means each of the data, where was it? All these 21, 22, 25, all these are the data, right? They want you to square them, 21 square, 22, oh my God. Not nice. Okay, here. So 21 square, 22 square, 25 square, and all that. Square, each of them, all right, x square, and then you sum it up. That means you add all of them all the way to 46 square. Yes, it's going to give you a gigantic value. Yes, no problem, don't worry, okay? Then divided by n, again, n means how many data are there? 16, okay? Then minus, x bar, remember, it was a symbol for mean, It was a symbol for mean. That means mean we already found what? 33.125. And then they want you to square it. That's it. Okay? So actually, it's not hard. It's just that you need to understand what does this symbol mean only. Then you just plug into the formula. Okay, this whole thing, if you're pressing calculator, you will get the value of 58.73. Done. Okay, that's the variance. So lastly, if you want to find standard deviation, all you need to do is just square root the number, 58.73. Done. That is, you will get 7.66. Okay? You see, I use one question and I basically covered, I would say 80%, 80 to 85%, all you need to know. for ungrouped data. Right? All the calculations, all the important calculations are all here already. Okay. Some student might ask me, teacher, so we have covered, you see, okay, out of all of these calculations, yes, we have covered range. I show you how to do range. Okay, I show you how to do interquartile. I show you how to do variance. I show you how to do standard deviation. Okay, I also show you how to do mean. Right, just now we did mean. I show you how to do median also, rearrange and then find the middle, but we didn't do mode. So some student might ask me, teacher, how to find mode? This question, you look at this data here. Mode, remember, it sounds like most. So guys, in the chat box, is there any mode? What is the value of mode? Is there any mode in this question? That's my question. Is there any mode in this question? Yes or no? I show you the data again. My question is there any mode in this question? In this data? Got mode or don't have mode? Thanks, Ishan. Right? Because the value of mode, remember mode means most. That means which data appear the most. No, I totally agree with Ishan. Okay, because none of the data got repeated. All data only appear one time. There's no repeated data. So actually, I wouldn't say there's no mode. I would say every single data is the so-called the mode, because all of them appear one time only. Okay, so for this case, for this particular question, mode is not useful. Mode is not useful. Okay? Okay, so that's it for this question. Let's move on. Okay, this one is another type of question. They love to ask this comparison ready. This one, you see, they just ask you to draw a box plot, right? They didn't ask you to compare. Now they want you to compare. Okay, another type of question. So if you read the question, it says, Table 2 shows the score of two participants, participant A and B, in a shooting competition. Okay, so looks like participant A, these are the scores. Participant B, these are the scores. Okay, can, no problem. Okay, then what do we have to do? Part A, determine the measure of dispersion used to select a more consistent participant. Did I not tell you guys just now? When they ask which one can measure dispersion to find consistency, which one out of these four, which one? Actually, if you ask me in practical, all four also can. But your SPM, they take this as answer, standard deviation. Okay, so for answer for this one, standard deviation. Then in other words, by calculating or by comparing the standard deviation, you'll be able to tell which participant has a more consistent score. Okay, all right, part B. Yeah, this one calculate the mean, variance, and standard deviation for. Can we skip this question? Because anyways, it's the same thing, right? So the formula for me, okay, let me just write down the formula again, right? It's the same formula because this one, this is ungrouped data, not group data. Okay, because each of the data is individual. Okay, so ungrouped data, we use the same formula as before. Sum of all of the data divided by n. So looks like 1, 2, 3, 4, 5, 6, 7, 8. There are 8 data here. So n is 8. Okay, so if you sub it in, okay, I just straight away write down the answer. So at least for those who are willing to try, when you try this question, you can check your answer. Okay, but basically it's just sum up all the data for participant A divided by 8, then you'll be able to get 8.975. Okay, I just want to save time because anyways it's the same calculation, nothing much Okay, done. So this is the mean. Variant also same So variant, same formula we use for ungrouped data. Variant is this one equals to sum of all of the data squared. So you should square the data first and then add them all up, divided by n, which is 8 for this case, minus of the mean square. The mean you already found earlier. So just sub it in and then square. Press the whole thing to calculator. You will get 0.694. Okay, and then of course standard deviation is just square root the variant, square root variant. So if you do that, you're gonna get 0.833. Okay, this one nothing much lah. It's the same calculation all over again. Okay, this one is what I wanted to do with you guys here. Given that the values of mean and variant for participant B is this, okay. So they are good to you lah. They didn't ask you to find the mean and variant for both A and B lah. They just asked you to find for A, B. They should just give it to you. Okay. So, let me write it down. Let me write it down for participant A and participant B. Okay. The mean for participant A we counted earlier, 8.975. Participant B, the mean is 8.6. Okay. But the variance, okay, for A, it was 0.694. For B, it is 0.505. Okay. So this one. So, guys, now compare. Which one, mean or variance, will be able to tell you for part 1, most consistent? Which one is more consistent? So, which one should we use to tell us the consistency? Mean or variant? Which one? Mean or variant? Which one will be able to tell us about consistency? Thank you, Jing Hao. Variance, right? Because variance is directly related to standard deviation, right? So consistency depends on variance. So look like which one? So remember, the smaller the variance, the better the consistency. So looks like for this case, B, right? So participant B is more consistent because the variant value is smaller, more consistent. Okay, but guys, I know actually this one is the only question, but this question I come up with myself one. Okay, I want you, participant B is more consistent, but I want you to do part 2 also. Okay, who scores better on average? Yes, we know that participant B is more consistent. That when we say more consistent means the marks that the participant B is getting is closer to each other. Let's just say if you go back to the table, right? You see, okay, for participant B, the 9.1, 9.3, 8.1, 7.5. So this so looks like participant B is scoring between, this one is a bit outlier, a bit around 8 point something to 9-ish. Okay, more consistent. But if you look at participant A, right? Oh, this one the range is bigger. Wow, from 7.2 all the way to 9.9, 9.8 also got. So that's why consistency wise A is not very good because the score is more spread out. However, if I ask for who scores better on average, then you actually need to compare. So it depends on what the question is asking, right? Which one is better on average? You have to compare the mean now. So who has a bigger mean? A, right? That means A in general, participant A in general, he is going to score a higher score in general. It's just that he's not consistent only. So like most of the time he can score higher score, but sometimes he just suddenly cannot keep the consistency. Suddenly cannot do well like that. But on average, A is a better scores better. So A only needs to work on the consistency and needs to be consistent. So this one looks like participant A need to practice more. And then participant B is already very consistent, but the score is slightly on the lower side, right? At the lower mean. So what participant B can do, right, is to maybe hire a new coach. Maybe get a, I think this one is a sport, right? Yeah, it's a shooting competition. Yeah. So get a new coach lah, or change the shooting gear lah, whatever to improve the score on average. Okay. Okay. So how if ask who will be oh, okay. Jing Hao, don't worry for this type of question because the question have to be very specific on this. Like, for example, okay, who should the coach choose if the coach prefer a more consistent participant? Like that. The question will phrase it this way. Okay, so depends on the question. Okay, if lah, really touch wood lah, really touch wood lah, they really just ask you who will you choose and then ask you to justify. So actually this one up to you. For example, you can say, okay, I will choose participant A because although the consistency is lower, but he scores a better mark on average. If your justification matches with your answer, they will give you correct one. Maybe another student might say, okay, but I think I will choose participant B because although he scores slightly lower, but he's very consistent and his score as 8.6 is actually not too bad. It's not too low. Right? So consistently, he scores very consistently and the average score also not too bad. So I think I would choose for participant B. Also can. Okay, if your justification matches with your answer, then it's okay. Okay, but don't worry lah. They won't ask like that one. They will be very particular on the wording. Okay, nice. Okay, this one is the last part of question. Okay, last part of question before I move into group data. Okay, now this one. They love to ask this kind of question. Variance of this set data is 2. Calculate the new variance if the data is added by 2 or multiplied by 3. This type of question. Right? So this one we call it modification. So this one, super easy. Let's go back to where all of these are. So these are all the calculation you need, right? Mean, mode, median, range, interquartile range, variance, standard deviation. Total, you got 7. You got 7 things to calculate. Okay. Now, very easy only. If they say they do plus minus to the data, if they do plus minus to the data, the effect on all of those mean, mode, median, range, all that, no change. Yay. So actually, the first part of the question, calculate the new variance. If the data all added by 2. Addition doesn't change all of these values. So no change. That means the new variant is still equals to 2. It's still 2. Doesn't change. No change. Okay, plus minus is the easiest one. And then multiplication and dividing got effect already, but it's just do the same thing only. So the new value, if I multiply, then all of this mean all that, basically you just multiply by the same number. Okay, but there's one exception. There's one exception. All of these will change accordingly to what you multiply and what you divide. The only exception here is for variance. Okay, why? Because variance got square ma. You see the variance, even the symbol also got square already ma. So if you multiply by a certain number, right, everything else also multiply by the same number except variance. You need to multiply by the number squared. That's the only difference. So for example, this one, right, they say each of the data multiply by 3. So the new variant is just take the 3, but you don't forget to square it. Variant is the only special case that you need to square this. Then multiply by your old variant. Okay, your old variant, which is 2. So that means 9 times 2, answer is 18. Done. Of course, I can change the question. I said I want to calculate the new mean, let's say. Why not? Okay, I want to calculate the new mean for these 2 conditions. Can. Addition, no change. Okay. Multiplication got change, but you just need to multiply by 3 only lah. Just follow. This one multiply 3, then your new mean also multiply. New mode also multiply by 3. New whatever lah, IQR, standard deviation, everything multiply by 3. The only thing different is the variant. Need to square only. If it's divide, let's just say divide by 3, the same thing. Same thing, right? For new mean, new mode, new median, also divide by 3. But for new variant, make sure you divide by 3 square. like that. So actually, let me just write down here. The new value, okay, if it's division, then you take the original value divided by k squared, like that only. Everything else is just divide by k. Okay, I think this one is pretty straightforward, right? Nothing much lah. Okay, done. So this one times, let me just write this down nicely. This one times the old mean. Okay, done. Okay, so one last question. Okay, come. This one I purposely copy here. Okay, so that everybody can try. Everybody can try. Okay, I like this question. When I say I like this question means you should try it with me already. Okay, so this one. Okay, what do they say? Ida feels sad to find that the mean marks for her 4 elective subjects, bio, physics, chem, and maths in the mid-year was 67.5. Okay. So you have 4 subjects, bio, physics, chem, and maths. Okay. All of these, the mean was 67.5. Okay, that's what it is. Okay. So, but after some discussion and review, Ida managed to obtain additional marks. Okay, so managed to obtain additional marks for chemistry and maths. Okay, so this one add new marks. Okay, but add how much? Given that the additional marks of the chemistry, so whatever marks that she managed to add in chemistry is twice as the additional marks in maths. So that means, right, we don't know how many marks you add. But let's just say for MS, you add X amount of marks. In chemistry, the additional marks in chemistry is 2 times, is twice. That means you managed to add 2x. Okay, that's what it means. Okay, so you know what? Let me write this down nicely because I don't want to confuse this. Originally, it's just these 4 subjects. The mean is 67.5. Okay, but now, still the same 4 paper, but chemistry she managed to add 2x marks. Add maths she managed to add x amount of marks. Okay, and then I think the mean will change already. Yep, see, the new mean changed to 70.5. Okay, so the new mean now changed to 70.5. All right, become higher already. Yep. So calculate what does the question want? Calculate the additional marks for chemistry. So basically they want to calculate how much additional marks she got for chemistry. Means she wants to find out what is 2x lah. The additional marks 2x. The question wants to find out how much is that. Okay. So any idea, guys? Any idea? Any idea? Come. This one need to think a bit. Any idea how to do this type of question? Okay. Elimination. Elimination. Oh. So like this B plus P plus C plus MS is this much. And then this much plus 3x is equal to this one. And then minus. Good try, but no. Good try, but no. Why? Good try, but cannot. Why? Because Jinghao, this one is mean. It's not sum. You are thinking sum. Yeah. Okay. Good modification. Good. Okay. So guys, actually Jinghao is quite close already. Okay. What we can do is you find out what is the total marks first. Okay. Think if you want to find the mean for the 4 subject, right? All you need to do, if you remember how to find mean, you will take the total marks divided by the number of paper, which is 4, right? So now they tell you the mean is 67.5 equals to the total marks that we don't know over 4, So if you want to find the total marks for these 4 paper, all you need to do is just multiply by 4 to 67.5 times 4. Then you will get, okay, let me see, calculator. I get 270 marks. So that means these 4 paper all add up, the marks is 270. Okay? So that means, let me write down, B plus P plus C plus at maths, these 4 paper add up is 270 marks. Okay, now let's do the same thing for the new mean. After I add some marks for chemistry and add some marks for maths, right now the new mean became 70.5. So let's try to find out what is our new total, right? Try to find out what is our new total. So same lah, 70.5 is the mean of the new marks, right, for the 4 paper. You times 4. Okay, so the new total you're gonna get how much is that? Let me do a calculator. 40.5 times 4. 282. 282. Okay. 67.5 times 4. Yeah, 270. Yeah. So it looks like, right, these 4 paper added with total 3 x's. So B plus P plus C plus at maths plus the additional marks for this case is 3x equals to 282, the total marks. Okay, then once you reach here, okay, we finally can do so-called the elimination. So these 4 paper, these 4 paper together, it was 270 ma. So actually, you can just, okay lah, it depends on how you see this lah. Elimination also can, this one minus this one also can. This one, you want to sub this in also can, okay? So for me, I'll just sub it in lah. B plus P plus C plus AM is this one. The original mark is 270 plus 3x, you're going to get 282. Okay, and then do your algebra lah. Minus 270 on the other side, 3x equals to 12. So x equals to 4. Okay, done. Okay, so which means what does that x equals to 4 mean? It means at maths at 4 marks, chemistry at 2 times the 4 marks, which is 8 marks. So chemistry, she added 8 more marks. So that's why I purposely want to choose this kind of question. When I saw this question, like, good question. Let's try this. Okay? Any question? Please go ahead and ask in the chat box lah. Don't have to wait there. Okay. So let me move on first. Okay? Got question, just type. One thing also, this room chat, I realized if somebody is typing, I wouldn't know because there's no like the ... right? Like if somebody is typing, then sometimes it's like typing ... They got a comment there, but this one don't have. So I don't know if any student, because some student might not type that fast. So I just want to say, if you are typing, you just go ahead, just finish your typing. Okay, don't worry that but teacher already move on to the next topic. No, don't have to worry about that. Okay. Okay, just nice. 1 hour we finish ungroup data. So the remaining hour, let's finish off group data lah. Okay. So for group data, of course the calculation are more or less the same, but I just want to point out these two. This is the main difference. Like if they ask for mean and they ask for standard deviation / variance, okay, for group data, this is the formula that I ask you guys to change really. Use the one with the F. F here means frequency. Okay, so I just want to point out when you go back to my summary here. Okay, so if it's ungrouped data, use this one. If it's group, we use F. Wait lah. Austin, I mute you. Okay. Okay, so sorry, a little bit of what. Okay, so anyways, the group data, we use the formula with the F. Okay, so basically I just copy these two and I put it right here. Okay. So some student, please don't get confused. Hello. This one is standard deviation. So I put this symbol that stands for standard deviation and I put a square root here. So if anybody, the question asks you to find variance, you know that it's this lah. Variance. Okay, it's just whatever within the square root. This one here. Minus this one, square. Okay, whatever inside the square root, that's variance lah. Okay, done, huh? Okay, so I think let's just straight away jump into the calculation. Let's just jump into the question, okay? Now, what? Oh man, I don't like this question. Wait. Can we let me choose another question here. Okay. Let's just choose this one. Aiyo, that one I see the table. I also see it already. But don't worry, we will go back to that question. It's just that I don't like to use that question to demonstrate. Okay, so if you look at this question, okay, this table show the time. Okay, so this one is the time spent by 40 students. So guys, the value of this frequency just means the number of students for this case. Right, so if you guys are, what this means is there are out of 40, there are 5 students that spend 1 to 10 minutes at the computer lab. That's what it means. Okay, wait lah. Guys, give me a minute. Okay. Because yeah. Okay, so where was it? Yeah. So 5 students spend this much time. 7 students spend this much time. So guys, if you realize, if you add all of the frequency up, right? 5 plus 7 plus 9 plus 10 plus 6 plus 3, it should equal to 40 because you did the survey to 40 students. So all of them should be here. Okay? I just want to point that out. This one, 40 is the sum. I start to use the symbol. Sum of the frequency has to be 40. That means all of this number you add up must equals to 40. Make sense? Okay, so what does the question says? Part A, calculate the estimate mean and the standard deviation. So if you want to find standard deviation, obviously you must find the variance first lah. Okay, must find the variance first, and then after that you square root the variance. So part A, mean, this symbol. Okay, which formula to use? The one with the F. So let's copy and paste here. This one is given to you. Okay, so let me copy the FXF. Okay, let me put here sum of fx over sum of f. Okay, guys, you just need to understand what this mean, what these values mean. Okay, actually, I can put here. Okay, what this mean? This one you know already, man. This is sum. Sum of what? Sum of fx. Fx here means f times x. So f means frequency. F means frequency. X means just now when we did the ungrouped data, X is the data itself. So this is the data. However, but this is a group. It's not an actual, it's not like a specific number, right? So the X here that we should use has to be the midpoint. We use the middle value for each of the group to estimate to estimate the mean. That's why it's they always call it estimated mean, right? If this one is a fixed value, let's just say 9. Let's just say this one is 17. If it's fixed value, then yes, this can become the x. So f times x, no problem. But this one is a range, unfortunately. So if it's a range, takkan you take 1 and 10, right? So the one we use here is the midpoint. So x here, for this case, it means the middle value for each group. The middle value for each group. Okay? So let me just write nicely the x value here for this one. Okay lah, if you guys don't know what is the middle value, very quickly, just add the two values divided by 2. 1 plus 10 over 2, which is 5.5. Okay. Okay, let me just open up another column here. Okay, 5.5, so I don't have to keep repeating the x's. Okay, so this one middle value, 15.5. Okay. Yeah. Oh. Hey, where does it go? Okay, here. Okay, so 25.5, 35.5, 45.5, 55.5. Done. So these are my mid value, mid. Okay, so read this. You read this, what this means? Means the frequency multiplied by the midpoint 1 by 1 and then sum. That means then add it all up. So like 5 times 5 by 5. That's the first one. Next one, 7 times 15.5. Next one, 9 times 25.5. And then do the same thing for all, add it all up. Plus all the way until the last one. Okay, add all up, then over this one, sum of the frequency. Did I not just say that if I sum up all the frequency, okay, it should give you 40, right? So over 40, right? Press this whole thing to calculator, over 40. That's it. So answer here, I get 29. Okay, so actually the hardest part is not it's not what, like, it's just to understand what this formula mean only. Okay, this one. Fx means f times x. So you add everything up. This time this, this and 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 this, and add. Okay, done, huh? B, standard deviation. Okay, so I write SD lah, standard deviation. We are supposed to find the variance first. So let's copy down the formula for variance, and I just so happen that I remember. Okay, fx squared over sum of f minus the mean square. This is the variance formula, and then don't forget to square root because I want to find standard deviation. Okay, so again, what does this mean? What does this mean? This means same thing. You want to sum what? Sum f times x squared. F 5 times x squared 5.5 square, like that. That's the first one. Then the next one, F 7 times 15.5 square, Fx square. So do that one by one. F times this number square, F times this number square, F times this, one by one, and then add everything up. That's what it means by the first one. Okay, the top numerator here. Then over, this one same law, sum of the frequency. Take all of this frequency, add it all up, 40. Okay, minus, okay, sum, I mean, mean, this is a symbol for mean. Mean, we found it earlier already, 29. Okay, 29 squared. Then square root. Okay, don't worry, all of these are given in the formula sheet. You just need to know what it means only. Okay, so tap in calculator, I think you get 14.41. Done. Okay, that's it. So if you understand this, now let's go back to this question. Let's go back to this question that I'm like, oh, I don't like to do. Why? Because I don't like. Why I don't like to do this? Because you fill out one by one. But actually, it's good to you lah. They are trying to help you one actually. Okay, so let's see. So this table show the mathematics quiz marks lah for 2 classes, Budiman class and Jujur class. Okay, good that the Jujur class they already gave it to you. Okay, so let's do it for Budiman class. So same thing, you just need to follow the instruction only, complete the table, calculate the mean and calculate the standard deviation, which is the same as what we did just now. Okay, so but this one, they are good to you because they guide you step by step. Remember that if you want to do mean, right? If you want to do mean, right, the formula says you should use sum of fx divided by sum of f, right? So what does sum of fx means? F times x. You need to do one by one. F times the x, remember, which is the midpoint. You see? That's why you see this side they really guide you. They ask you to fill it up. So, okay, fill out one by one now. Midpoint 57. Okay. 62. 67, 72, 77, 82. Okay, you get all the x's already. Then what you're supposed to do? You're supposed to multiply f and x. You see the third column so good. They prepare this for you. So this one is just a lot, very troublesome. You need to do 4 times 7. Guys, I write the working down here. But in actual paper, you type this in calculator and write down the answer in the boxes. I just show you how to get the answer. Only here. Okay, like that. So multiply 1 by 1. This here means f times x lah. Okay, 1 by 1. Then sum. So all of these numbers, make sure you add all of them up lah. Okay, so I did this question already and I got 1695. I sum all of these up and I get this 1695. Okay? So that means your mean, this one we get the value already, 1695, okay, divided by sum of the frequency. So frequency is here, sum it all up. If you add all of these up, you see it, sum, I think you get 25. Yeah, you double check, I think, yeah, 10, 9, 19, 6, yeah, 25. Okay, so divided by 25, done. So this one, if you press in calculator, you're going to get 67.8. Okay? So next, yes, you see, they ask you to calculate the standard deviation, which is the variance first. Variance is like this over this one minus the mean squared. Don't forget to square root the variance. Okay? So let's start one by one. Okay, what does this mean? This means I want the sum of the frequency times the midpoint square, f times x square. So you see here, they really got you. They'll help you one by one. They want you to find the x square first. That means they want you to do 57 square, 62 square, 67 square, all that lah. Okay. 22 square. Under the square, then they want you to do fx square. That means f times x square. So whatever this value, x square, multiply with the frequency. So 4 times 57 square. And then do the same lah. You can lah. I let you, right? Basically, it's the same lah. Okay. So if you, after you get all this value, then sum it up. Why? Because the formula wants it. The formula wants to sum this column up. So if you do that, huge number, it's okay. 116405. That's what you're gonna get. So with that, now you can sub in already, okay? Numerator 116405 over a sum of the frequency, which is the same, 25, minus a mean, which we found it earlier, 67.8 squared. Okay, then square root. Okay, press this in calculator. You're gonna get 7.70. Done. Okay, that's it. So what else? Okay. I think that's it. I think that's it. Okay, this is for class Budiman. Class Budiman. Then part 2, they ask, which class performance is more consistent? So again, reminder, if they're asking for consistency, we should be looking at standard deviation, not mean, not mean. Standard deviation is going to tell us consistency. So the information is given here, but the mean and standard deviation wasn't given to us. So with this one, we have to do it ourselves. But it's okay lah. Since they already gave us all these important values, we just sum only. Okay, sum of fx divided sum of f. Sum of fx is here, 1670 divided by sum of f, which is 25. Calculator says 66.8. Okay, that's the mean. Standard deviation, do the same thing. Sum of fx squared over sum of f minus mean squared. That's the variant. Make sure you square root. So take this 112630 over 25 minus 66.8 squared, square root. You get calculator 6.55. Okay. So now you can compare. Now you can compare. This one is a Budiman class. This one is Jujur class. Okay. So looks like, right, who is more consistent? Consistency depends on the smaller standard deviation. So looks like Jujur, right? Jujur is more consistent. Jujur is more consistent because the standard deviation is smaller. Smaller standard deviation means more consistent. Okay, but if I can change the question, right? I say, which class performance is better? That means which class score a higher marks in the mathematics quiz lah. Okay, so if you want to compare which class score higher, you should look at the mean. So if you look at the mean, it looks like, wait, see, Budiman, in general, they are scoring a higher average, 67.8, right? Jujo is slightly lower. So to answer the question, Budiman, right, this one is scoring a higher, scores higher, score better, like we say. Score better, right? Why? Because the mean is a bigger value. Okay, so you see, depends on what the question is asking. Consistent means standard deviation. Who do better? You have to look at mean. Okay, done. Okay, I hope this clarifies the calculation for mean and standard deviation lah. Okay, for group data. Okay, some student might ask, teacher, can we find the what do you call that? Mode. Mode. Okay. You know what? I just recalled. What is the mode for Budiman class? Okay, come. Come. Or another way that can ask, what is the model mark for Budiman class? Mark range. Okay, in the chat box, guys, I want you guys to tell me if in case the question asks, what is the model mark range for the Budiman class and the Jujo class? Let's look at the Budiman class first. Model, the word model comes from the word mode, comes from the word mode. So mode sounds like most, right? Sounds like most, most, okay? So which one are you seeing? Which one, right? Looks like, right? Out of all of this range, right? Budiman class mostly score this one, 6 of them. Highest number of students, 6, score between 60 to 64. So the model mark range is 60 to 64. That's the answer. Okay, because it happens the most time. But Jujo class, majority of them, 8 of them, and the highest number of students, score between 65 to 69 marks. Okay, so that's the model mark range. That's how you read it. Okay. Okay, so that's it. No questions here. If got question, ask lah. Okay, so let me move on first. Okay, because then we will now we get into the last part of group data, which is drawing lah. They love to ask you to draw. So very quickly lah, this one. Okay, there are 3 ways they can ask you to draw. One is histogram. Okay, histogram looks like bars lah, like this one. Got bars. Okay, got bars like that, like that. Got bars. So one thing you need to understand is for histogram, the x-axis is lower and upper bound. This one lower bound, this one upper bound, then lower bound, upper bound shared, and then here. So you should use the lower and upper bound for places for where you draw the bars lah. Okay, so not to worry. I have a question at the bottom there here at later. Okay, we will go through how to draw histogram. So use the lower and upper bound. For y-axis, you use frequency lah. Okay, that means for each class got how many students, how many people are that frequency. Okay, that's histogram. Frequency polygon is the next one. This one very similar to histogram, except you see the axis also use frequency. See, for both frequency polygon and histogram, both the y-axis you use frequency, but the x-axis, instead of using lower and upper bound like histogram, you use the midpoint, middle point. So let's just say the midpoint is here. So you mark. So midpoint of the first class, you mark what is the frequency. Midpoint of the second class, you mark maybe the frequency is here. Midpoint of the third class, maybe the frequency is here. Maybe fourth class, the frequency is here. Something like so. All of these are midpoints of each of the range. Okay. Then all you need to do is just connect, and connect, like that only. Okay, that's it. Ogive. Seriously, I'm very tired of. Is it Ogive or Ogive? Let me just very quickly Google how to pronounce this. pronunciation. I cannot tahan. Orgive. Okay, orgive. Okay, orgive. Okay, so where is it? Okay, so how to draw? Okay, sorry, I have to very quickly Google it. Okay, for orgive, your x-axis you have to use the upper bound. So if you know how to do histogram, right, then you should be able to know how to do orgive already. Why? Because histogram use lower and upper bound. That means if you know how to draw histogram, means you must know how to find lower and upper bound lah. So all you need to do is take the upper bound for each class and put it here. Upper bound, upper bound, upper bound, upper bound, upper bound, upper bound, like that for each class. Okay. Then for each class, right? This is the special one. Y-axis is no longer the frequency itself, but the cumulative frequency. Okay. Don't worry. Later we have a question. We will do it together. Okay. But anyways, the shape of the orgive is very special lah. It looks like an S shape lah. So let's just say something like this lah. It always look like an S shape one. If you don't get a shape like this for orgive, you know something is wrong already. Okay, histogram and frequency polygon, this one can be any shape, but this one for sure is S shape. Okay, so here you see, guys, I have an example of orgive here. Example of an orgive. Okay. So if you look at this, you see all these points here, 34.5, 39.5, all of these are the upper bound for each class. Okay, must have a range, but all of these values here are upper bounds. Okay, then what you need to look at is this one. They love to calculate. They love to ask you to calculate. Okay, so let me demonstrate very quickly. First thing first. If you look at the cumulative frequency, the maximum frequency here is 100, right? That means, right, if you add up all the data, how many people you ask the data, right? The number of data that you get, 100 is the answer. That means you have collected 100 data because it shows up here as the maximum. Okay, so out of the 100 data, let's do median first. I think median is easier. Okay, we know that median means you are at the middle of the data. You collected 100 data. That means the position of the median must be at the 50th place. This one here must give you the median, right? But a lot of students, they will say, oh, teacher, then median is 50. Wrong, guys. No, the 50 is just telling you the location of the median. That means at the 50th place. That is where the median happens. But what is the actual amount of median? You have to read it from the x-axis like this. So go all the way here, draw, and then from here, go down. This value right here at the x-axis, this will tell you the actual value of median. So that's why I want to be very, very clear here. The position of the median is half of the cumulative frequency at 50. At cumulative frequency equals to 50. That gives you the position only. But the actual value of the median is this one. So you have to zoom in. I know your eyes pain. Very hard to read here. But this one is, oh my God. What is it? 50, 51, 52, 53, 54. Yeah, so this one is 50.5. 50, 51. Okay. 50.5 plus 51.5 divided by 2. That is 51 in the middle. And then so this one is 50.5 and 51. So 50.75. So the actual value is 50.75 seconds. Seconds. Done. That is the median. This one here is the median. This tells you the position only. Let me erase this. This only tells you the position of the median, 50. But the actual value is here. Okay, so same thing for first quarter as third quarter. Okay, remember, first quarter means, okay, From 0 to 50, that's the first half, right? So first quartile means the half of the first half. So means from 0 to 50, half of it is 25. So right here, 25. This will give you the first quartile. Okay, so let me measure quick all the way to here. Okay, then let's see, and then put here. Okay, oh, just nice. I think this one, yay. No need to read so much. Okay, so this one, I think just nice. This one is ngam at 44.5. So this one is our Q1. Okay. At cumulative frequency equals to 25. So the actual value is 44.5 seconds. Oh. I want to erase. Why cannot erase? Whatever. Okay, next. Third quarter. I hope you guys can see already. So middle is at 50, right? So third quarter must be in between 50 and 100, which means it has to be at 75. Okay, 75. So do the same thing. Okay, let me do as fast as possible. Fill this up. And then pull it all the way down. Whoops. Here. So I think this one also just nice because it's right here. Yeah. Bing. Yeah, here, 54.5. So this one give you Q3, but the actual value of Q3 is right here. Okay, so 54.5. 54.5 seconds. This one is at cumulative frequency 75. So done. Okay, normally they will ask for these three, and then well, normally if they ask for Q1 and Q3, right, then this is where they will ask for this IQR. They ask for what is the value of IQR. So value of IQR again, Q3 minus Q1. Please, don't take the location and minus. It's the actual value that you need to use. So Q3 is 54.5 minus 44.5. Answer is 10 seconds. Okay, if they ever ask, normally they would. Normally they ask for Q1, Q3, and then they ask IQR already. Okay, the last one here, before we get into a question here, 30th percentile. 30th percentile. So 30th percentile, what it means is the location is at 30% of the max. So 30% of max here is 100, right? So if you do calculation, 30 over 30% of the maximum position, which is 100, that means the position, the cumulative frequency position must be at 30. So at 30, this one here, this value here is going to give us the 30th percentile. That's what it means. So guys, as you realize, right, all the median, whatever, Q1, Q3 percentile, all that, right? The actual value is never the y-axis. It's always at the x-axis. Because the x-axis is the actual data. The y-axis is just the frequency only. Okay, so right here. Okay, so if I were to zoom in, okay, my 30. Where's my 30? Okay, so my 30th percentile is right here. So you come here all the way down here. Oh my God, what is that? 45.5, 46.4, 45. That's 45. So this one here, let me label this. This one is my 30th percentile. Median is here, Q3 is here, Q1 is here, middle percentile is here. This one. Okay, so I say 45, right? No, 45.5, 46.5, 46, 46, 46 seconds. Okay, done. Yeah. Right, nicely. Okay, done. 46 is right here, 46. Okay, I hope this clarifies how to find, because whenever they ask you for all guys, right, For sure already lah. This one of these would have, one or more of these must have come out one. Okay? So if you guys understood this, right, let's straight away jump into the question, okay? Let's straight away jump into the question. Okay, this then come back to the same question, but part A we already did lah. So let's straight away do part B already. So what does part B say? By using the scale of 2 centimeter to 10 units in the horizontal axis. So here, that means this one, okay, I measure already. This one is 2 centimeter. Hey guys, when you go to your SPM, please make sure you measure. Okay, one big box should be 2 centimeter. So every 2 centimeter, they say must equivalent to 10. So 10, 10, 20, 30, 40, 50, and so on. But you have to read what they want you to draw. They want you to draw histogram. So if you guys remember histogram, the values here must be the lower and upper bound. Lower and upper bound of each of these classes. Okay? So let's do that very quickly. Okay? Let's do that very quickly. So what does it mean by lower bound, upper bound? Let's just look at, for this one easier lah. You see from 10 to 11, the middle value between 10 and 11 is 10.5, right? So that means 10.5 is the lower bound for this second class. Then 20 to 21, the middle value is 20.5. So that means 20.5 is the middle, is the upper bound. Let me just erase this first. This one here. Okay. So this one here, 20.5 is the upper bound for the second class. So as you can see, right, this upper bound for the second class, 20 and 21 is 20.5. The same value will come to become the lower bound. So that's why I say the upper bound of the previous class will be shared with the lower bound of the subsequent class or the next class. Like that. So this one also this one is 10.5 is also the upper bound of the first class. Now this one is 1. So you look at the pattern 10.5, 20.5. I think here is going to be 30.5. So looking at the pattern looks like it's all 10, 10, 10. So this one must be 0.5. Okay, this one lower bound, this one upper bound, like that. Okay, so let me just fill this up very quickly. 30.5, 40.5, 50.5, and 60.5. Okay, this one 40.5, 50.5. Okay, so that means when you draw, okay, now we are ready to draw our histogram. For the first bar, you have to draw from 0.5 to 10.5. So for me, right, I'm just going to label this one as 0.5, really easy for me. Then the next one, 10.5. So my first bar is going to be somewhere like this, a rectangle bar like that. My second class from 10.5 to 20.5, right? So I can share 10.5. The next one is 20.5. So this one, 30.5, 40.5, 50.5, 60.5, done. And just nice. See, 60.5 is the last one, just nice. Okay, that's what it means. So ask yourself, is the gap 10? 10 units, 10 units, 10 units? Yes. So it fulfill the 2 centimeter to 10 units. Okay? Okay, vertical axis, 2 centimeter to 1 student. That means 2 centimeter, this has to be 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this one, if you remember, this one has to be the frequency. Okay, for histogram. So you see, you guys need to remember this one. That's why I summarize everything here already. The X and the Y axis for each of the diagram, you need to know what you need to put for X and Y axis. Okay? Okay, so with that being said, I think we can draw already. So for the first bar, the frequency is 5. So for the first bar from 0.5 to 10.5 is 5. So done. Okay, it's gonna be messy because no ruler. Okay, then wait, I suddenly think of a better way. Ta-da! Okay, rectangle. So for the second class, the frequency is 7 from 10.5 to 20.5, 7. Ding. Yay, damn. Okay, let's go. Okay, next. The third class, 9. Okay, so straight away, 9. 9. Boom. Okay, next. Copy and paste. Okay, 10. I think so. The next one is 10. Yeah, 10, and then 6 and 3. Let's go. Yay. 3. Okay lah. Okay lah. The first one, I think we can make it nicer lah. Very ugly. Okay, the first one, it was 5. Okay. Nice say. Nice. Nice say, nice say. Okay, done. This is my histogram. Wow. Perfect. Okay, done, huh? Okay, so with that being said, we can answer the part C. Okay, state the number of students. Okay, let me zoom in. Okay, state the number of students. That means they want the frequency lah. Okay, number of students means frequency. Who serve the educational portal for more than 40 minutes. More than 40 minutes. So up to you. You can look at the table also can. You want to look at your histogram also can. But the question is asking for more than 40 minutes, right? That means 41 to 50 minutes is already more than 40 minutes. So 6 of them already fulfill what part C wants. Okay, 6 of them. 51 to 60 also more than 40 minutes. So this one also count. So there are a total of 9 students. 6 plus 9. Total 9 students that satisfy part C. Done. Very easy. Okay lah, this one, if you don't know how to do this, that means you just don't understand what the question is asking. But the moment you do, this 1 mark is a free mark question. Just look at the table also can. You look at the frequency, this one also can. If you want to look at this histogram, right? More than 40 minutes is here. Remember the axis. Oh yeah, don't forget to label the axis. The axis here is the time. Okay, time. Minutes. Okay, so 40 minutes is here ma. More than that means this 2 bar. This 2 bar more than 40 minutes is this 2 bar. So this one got 6 people. This one got 3 people. So total 9. Like that also can. You want to look like that also can. Okay, done. Okay, I think we have one last question to go, guys. Or guys. And then we'll call it a day. Really call it a day already. Okay, come. Let's bear with me. Let's do this together. Okay, come. Table 4 shows the cumulative frequency. Okay. Complete this table for okay. So this question actually I modified a bit because the actual question they did actually give you these values already. But we are doing revision, so I want to demonstrate how to do this lah. Okay, so the word cumulative means cumulative in English means collect, right? So group everything up, sum everything up, add everything up. That's called cumulative. So all you need to do is just, okay, the first frequency, nothing much to add first. So this is 0. But when you go to the second class, right, initially you have 0 frequency. The next class you have 2. So cumulatively speaking, that means you collect all of the frequency together, 0 plus 2, you will get 2. So your cumulative frequency for the second class become 2. Okay, when you go to 3, cumulative frequency all the way until class number 3. That means you group all the frequency up until here. So easier way, you can just use your previous cumulated frequency 2 plus 3. So you get 5. That means all the frequency you add up until here, got 5 people already. Then same thing, do until here. All you add up, okay? Either you can do 2 plus 3 plus 3, or easier because 2 plus 3 you already did it here. So 5 plus 3, 8. Accumulated all here, you will get 8. This is the word cumulative means you add all up, you sum it all up. Okay, English word lah. So same thing for the next one. So straight away, just all these 3 add together is 8 already. 8 plus 4, 12. Then 12 plus 5, 17. 17 plus 1, 18. So if you don't believe, if you add all of this up, 2 plus 3 plus 3 plus 4 plus 5 plus 1, all of that, you press the calculator, it should give you 18. That means that's why the last value of cumulative frequency is always the sum of all the frequency. It means all the total number of students, the total number of whatever data that you collect lah. Okay, done. Okay, the next thing, upper bound. They want to fill. You see, you know already one. They give you this, and then you see what they want you to draw. Part B, they want you to draw cumulative histogram. Oh, okay, never mind. Later we can do this together, cumulative histogram. And then ogive, you see? So you know already what ogive means. You need cumulative frequency for y-axis, x-axis you need upper bound for ogive. That's why they ask you to fill out this table. Okay, so let's do that. Upper bound. Upper bound means here lah. 39 and 40, the middle. 39.5. Okay, next 49 and 50, 49.5, 59.5. Okay, so looks like it's quite consistent now. I think for SPM questions, right, normally the upper bound, lower bound is quite consistent. But if we do international, you know, the IGCSE paper, sometimes they try to trick students. Sometimes this might not be consistent. You need to really look at these values. But I think for SPM, they make it very consistent. Okay, done. Okay, so we fill this out already. I think we can start drawing the graph. Okay, part B, this one they want cumulative histogram. So when they say cumulative histogram means normally histogram we use just frequency as the y-axis. But since they use the word cumulative, means all you need to do is just change this axis to cumulative frequency. Then later when you plot from here. That's what it means. Okay, so let's put in the values first. Okay, by using the scale 2 centimeter to 10 marks on the horizontal axis. Horizontal axis is the same as just now, right? It's like maybe they want 10, 20, 30, 40, like that. Okay, every 2 centimeter 10 units. But remember, when we draw histogram and ogive, we're supposed to use the boundaries, not the actual marks here, not the 30, 39, no, not this 30, 40, no. We have to use the boundaries. So I think I would do that. 39.5. I will label this with the boundaries. 49.5, 59.5, 69, 70, 80, 99.5. Ngam. Nice. Okay, and don't forget to label the axis. This one is the marks. Okay, marks. Oh, it disappeared. Oof. Okay. Then I label here marks. Okay, done. Okay, then what do they want for horizontal vertical axis? 2 centimeter to 2 pupils. 2 centimeter to 2 pupils. So 2, 4, 6, 8, 10. Okay. 2, 4, 6, 8, 10. Nice. Okay, done. So once I have this, now I can draw cumulative. Okay, histogram means must have bar. So let's do the same thing here. Must have the bar. Okay, must have the rectangle. So the first one is from 30 to 39, 0. So that means from here, 0. 0 no need to draw. That means 0 no need to draw. Right? Cumulative frequency 0. That means nothing. Okay. So straight away go to the next one. This one is from 40 to 49, which means 39.5 to 49.5 here. 2, the cumulative. Remember, we are drawing cumulative frequency because this is cumulative histogram. So we should use this column. So 2 here. Okay, done. Okay.